Hey guys, I wanted to go over Module 46 because it's talking about the air pollutants. And there's a lot of them and it can get confusing on how they're organized. So I just wanted to set up a way to organize them in your head. But first, before we do that, I want to talk a little bit about Chattanooga. Chattanooga is a city in Tennessee, right over here, that that is surrounded in mountains. It's sort of in a bowl, so it's down here. And the industrialization of the city had a negative impact on the environment because the pollutants get trapped and they can't escape from the mountains, over the mountains. And so the particulate matter was considered to be the worst in the country. I want to talk about this because we need to solve for our FRQ. We need to be able to solve an environmental problem and propose a solution. So here is our environmental problem. We have too much air pollution in Chattanooga, and so we've identified it. It is happening because of the mountains trapping the air pollutants, and because of the industrialization. So because of the cars, because of burning waste, the particulate matter was building up, and it was causing people to have respiratory problems, and it's bad for your skin, for your tissue, and for plant tissue. And so, along with another county, Chattanooga created its own air pollution control ordinance. And what they did is they controlled sulfur oxides. They put regulations on odors and dust, meaning the types of things that you can use or use in excess of. How much dust is it creating? What are the odors that it's producing? They outlawed visible automobile emissions. They capped the sulfur content at 4%. We're going to talk about sulfur caps later on. And they limited the visible emissions by industry. So even industry had to limit the amount of particulate matter that they were releasing into the atmosphere. So equally as important, what they did is they instated monitoring techniques as well. So they implemented regulation, but they also implemented enforcement, which is really important because you can have all of the regulation in the world, and if it's not enforced, it isn't going to do any good. And so if you were to be answering an FRQ about this, and you were to propose solutions, I would want you definitely to say that you need to create regulation. I would want you to also say that it needs to be enforced or monitored. But I wouldn't want you to stop there because that's a really broad answer. I would want you to go into specifics. I would want you to say that there were regulations on odors, that you would regulate the amount of odor or dust, or you would cap the amount of automobile emissions that are being emitted. And you would allow people to burn with permits only. So those are the specifics that I would want you to include in your answer. So what did Chattanooga do? How did they solve this problem? They poured $4 million into a cleanup effort. People worried about it would hinder the economy, but in fact it improved in some ways. Some people did lose their jobs when the industry died out, but they established a new smoke scrubber industry. And in 3 years, Chattanooga was in compliance with the clean air standards. People's health were better. And instead of burning garbage, they started recycling And to increase the amount of public transportation, a municipal fleet of buses were manufactured locally and increased group transportation. So this is exactly an example of solving a problem. They identified a problem and created a solution. And so those are the types of solutions that I would want to see. So when we are talking about air pollution, we want to keep in mind that it is a global system, that our atmosphere is a global system. What we do in the United States is going to impact wherever the atmosphere is being blown, wherever the wind blows it. And so we can see an example of this. The air pollution in Asia has been responsible for the acid rain on the west coast of the United States. So while the effects are not hindered by political boundaries, the costs and negative consequences are. So while Asia has been producing all of these pollutants, it is our people that are getting respiratory diseases. It is our trees that are getting acid rain rained down on them. So we have to remember that atmosphere is a public resource. It is a global commons. And so in order to keep the air clean and our respiratory tracts healthy, in 1970, the U.S. Clean Air Act was instated. 6 pollutants were identified as the most significant to human well-being. Sulfur dioxide, nitrogen oxide, so our SOx, our NOx, carbon monoxide, particulate matter, tropospheric ozone, and lead. Later in 2007, we identified carbon dioxide, VOCs, volatile organic compounds, and mercury were also said to be problematic, to the point where they added them to the U.S. Clean Air Act. So what I'm going to do is just go through each of these and give a brief understanding of them and sort of tie it all together so that it's less confusing. So sulfur oxides, SO2 essentially, or sulfur dioxide, is a corrosive gas that comes from combustion of fossil fuels, such as coal, oil, and gasoline. So like everything, it has it's a respiratory irritant, and it negatively impacts plant tissue or tissue. So how does it get into the atmosphere? Because living things contain sulfur. When fossil fuels are combusted, they are going to release sulfur oxides. And so they also are going to be released with naturally in volcanoes and in forest fires because you're burning plants and trees and so forth. So when the sulfur is released into the atmosphere, it's going to interact with the atmospheric oxygen and create sulfur dioxide. Next, we have nitrogen oxides. We have nitrogen monoxide and nitrogen dioxide. These are going to be produced at any point when combustion occurs because the atmosphere is composed of 98% nitrogen. And so, and then there's also, I believe, 16% oxygen. And so whenever combustion occurs, you're going to have the oxygen interacting with the nitrogen, and it's going to create nitrogen oxides. And so nitrogen monoxide is a colorless, odorless gas, and nitrogen dioxide is a reddish-brownish gas. And once they're created, they're going to transform one to the other. So they're going to sort of swap that oxygen from nitrogen dioxide to nitrogen monoxide, and it's going to sort of go back and forth. Next, we have carbon oxides, carbon monoxide and carbon dioxide, which we should know well at this point. Carbon monoxide is a pollutant. It affects our blood. It goes into our blood, and it doesn't allow your blood to hold oxygen. And so you end up, if you have too much in your blood, you end up sort of suffocating or not getting oxygen to where it needs to go. And so this is a dangerous one, and it is formed during incomplete combustion of most matter. So if matter is combusting at a colder temperature, you're going to have more carbon monoxide. Whereas at higher temperatures, you're going to have complete combustion. So this is a significant component of air pollution in urban areas because all of the cars. And it can be really dangerous if it happens if your heater malfunctions and it releases carbon monoxide in your house, because then it's trapped. And then you breathe it in and you don't know that you're breathing it in because it is colorless, odorless gas. So that's really dangerous. It's also problematic in developing countries because people cook with kerosene, they cook with manure and charcoal, and they do this inside in poorly ventilated structures. So when there's not gasoline to cook with, people will find anything that they can burn to try and cook their dinner, to try and get warm. And so this is going to be problematic to people in those countries. So what can they do? They can open windows, they can open doors, they can cook outside. Carbon dioxide is a colorless, odorless gas, once again formed during the complete combustion of most matter. And so monoxide is incomplete and dioxide is complete. We know all about how it is absorbed during photosynthesis and it's released during cell respiration. Um, and so generally, the complete combustion of matter into CO2 is preferable because it isn't going to impact our breathing. It isn't going to affect us as much. However, it was added to the act because we have reached over 400 parts per million, which is really dangerous in the atmosphere, and it's contributing to global climate change. And so therefore we need to take it into consideration. The next pollutant we're talking about is particulate matter or particulates. These are solid particles that are suspended in the air. Just as you would think, it comes from combustion of wood, once again animal manure, biofuels, coal, oil, gasoline. So people that are inside their house cooking with animal manure, cooking with charcoal, they're going to have an increased amount of particulate matter that they're breathing in, and this is obviously not good for your respiratory system. So diesel-powered vehicles are going to give off more particulate matter. As you can see, when they drive, they release that darker smoke, and so it can come from road dust. If you ever drive down a construction site, you can see where they're dropping water on the ground, and it's just to try and keep the dust down, because if you breathe it in, it's problematic. It can occur naturally in volcanoes, forest fires, and dust storms. So particulate matter is going to range in sizes. It's as small as 0.1 nanometers, micrometers, to 100 micrometers. And to give you sort of reference, a human hair is about 50 micrometers. So here is a human hair 50 micrometers across. Particles larger than 10 micrometers are not regulated by the ETA because your nose and throat, the wetness of that is going to filter it out. And so it's not really a problem. You might want to drink a glass of water if you've been around too much particulate matter that's greater than 10 micrometers, but it's not going into your lungs. Particulate matter that is smaller, or PM10, that is smaller than 10 micrometers are a concern because they are making your way into your respiratory tract. And even more of a concern is PM 2.5 or 2.5 micrometers, because it's going to lodge, because it's smaller, it's going to lodge even deeper into the respiratory tract, and it tends to be more toxic. This is going to be the materials that you burn that are going to be like in a smoke form. They're very small. You can inhale them, and they get lodged deep in your lungs. They can also scatter and absorb sunlight. So in high concentrations of particulate matter, let's say like a forest fire, the sunlight is going to be dispersed. It's going to be reflected. It's going to be absorbed. It's going to be referred to as haze. And in 1816, a year after an eruption in Java, there was 150 million metric tons of particulate matter. And so this blocked the sun, and it was referred to as the year without summer. And here is a picture of that. All right, we are down at the end of one of our initial pollutants. So lead occurs naturally in rocks and soil and in coal, so it's just naturally occurring. So remember that natural isn't always good, and good isn't always natural, because natural things can hurt you as well. So natural is, when you're talking about the word natural, and it being healthy, it's not necessarily true. So anthropogenic forms of lead, they used to be added to gasoline to improve performance. However, the amount of lead in the atmosphere became pervasive. It was actually found in the South Pole, in the North Pole, and it became problematic because it negatively impacts pretty much everything. Intelligence, learning, your bladder, your kidneys, everything. And so it's a really toxic pollutant. And so in the 1980s, it was phased out of gasoline.